Hey guys, today I'm going to go over your study guide for our plane geometry and similarity unit. I don't suggest that you watch this video all the way through. I suggest that you do the study guide, check the answer key against it, and make sure that you understand why you got the ones you got right correct, and what the ones you got wrong. If you have any questions about why you got something wrong, my suggestion is going to be to go through this video and skip around to those ones that you got wrong and you don't understand. So go ahead and do that, and then come back to this video and press play whenever you're ready to check. All right, so I'll get started by doing number one. It says I can use formulas to find the circumference of a circle, and it's asking you to find the circumference of this circle. So you're going to be using formulas for all these. You're usually given a formula sheet, so make sure you have that with you, or else memorize some of these formulas. So circumference means it's like the perimeter of a circle. It's the length all the way around it. You use the formula, circumference equals diameter times pi. The diameter is the distance all the way across the circle, and that is given to you here. It's 11. In terms of pi, that would be 11 pi. But if you want to estimate or simplify this one more step, you can use 3.14 for pi to approximate, or you can use the pi symbol on your calculator. When you do that, you should get about 34.54 centimeters. And remember, that's not centimeters squared because it's just the distance around the circle. Number two is a little bit different because it gives you the circumference and it tells you to solve for the radius. So we're still going to use the formula we used here in problem one. Circumference equals diameter times pi. We also know that the diameter is just 2 times the radius. So I'm going to rewrite the formula. Instead of writing diameter, I'm going to write 2 times r times pi gives me circumference. Now I'm given the circumference. I'm going to plug that in for c, and I'm going to estimate 3.14 for pi. Now that I plugged in all my values, I have an equation because I have an equal sign, and I have a variable. When I have an equation with just one variable, I can solve for that variable. I do that by drawing a line on the equals, simplifying what I can on the right, and then using inverse operations to get the r by itself. So I know that since it's being multiplied by 2, I can do 3.14 times 2 and get 6.28, and then take 28.26 divided by 6.28, or I can just take 28.26 divide by 2 divide by 3.14. Either way, you'll get a radius equal to 4.5 or 4.5, and you can check that by plugging in the radius into your equation to find circumference. So 4.5 times 2 times 3.14 will give you the circumference 28.26. Let's go ahead and take a look at number 3. It's a word problem, and I would suggest that as you read it, you draw a picture. So I'm going to do that. It says a little girl stands on a carousel, and you've been on a carousel. It's a little horse that's riding around in a circle and rotates around the ride 6 times. If the distance between the little girl and the center of the carousel is 8 feet, how many feet did the little girl travel? So I drew the carousel. It's the shape of a circle. The center is here, and it's 8 feet between the center and the little girl on the outer end of the carousel. So she has rode around the ride, and she's done it 6 times. So you're going to find the circumference and then multiply it by 6. Do that with the same formula we've been using. Circumference equals diameter times pi. You're not given the diameter here, you're given the radius. So plug in double the radius in for the diameter, since diameter is double the radius. So 16 pi, which you can approximate to about 50.24, and that is in feet. And since she went around 6 times, again, you're going to want to multiply that by 6 to get the total distance that she went around the carousel. That is approximately 301.44 feet. The first 3 questions are about circumference of a circle. The next 3 questions are about area of a circle. So there's a different formula for area. So when I ask you to find the area of a circle below, you're going to want to start by finding your formula for area. A equals pi r squared. I remember that always by thinking a pi r squared. And then I think, no, a pi r circled. No, a pi r squared. And I always think about it like that. So the area is going to be all the space shaded inside of here. You're going to need to plug in some values into your formula. So the value you need to plug in is r. Radius, again, is half the circle. So I know that it is half of the diameter. If the diameter is 12, the radius is half of that. So 6. And I can just plug that value into my formula. And I'm estimating pi to be about 3.14. So I'm using that number so I can get an estimate of the area. Using your order of operations, you know you need to square or take the exponent here before you can multiply. So take 6 squared. Remember, that's not 6 times 2. That's 6 times 6. That gives you 36 times pi, 3.14. And that will give you about 113 4/10 of a square foot. So that is the square footage or the space inside of this circle. Let's look at number 5. It's a word problem. It says a cell phone tower picks up signals within a 25-mile radius. It's a real-life example of radius. How many square miles of coverage does the cell phone tower provide? Anytime you see a word problem, I suggest drawing a picture. Let me give you a second to do that right now. Just kidding, can't draw. So here's a picture of it. The cell phone tower is in the middle, and the radius that it picks up all these cell signals within this circle. So the radius is 25 miles. So I'm going to write that here for the radius. Now it says how many square miles of coverage? So how many miles are all in this area that this cell tower is covering here? I need to use my formula for area of a circle. A equals pi r squared. I substitute in my values. I use 3.14 to approximate pi, and I put in 25 for the radius because that's what the length is halfway across this circle. I need to square that first and then multiply that by 3.14. When I do that, I get a total area of 1,962.5 square miles. And I just want to let you know, this stuff about cell phone towers and radius of a cell phone tower, this has been used to solve murders before. I mean, this has been used to determine whether someone could have committed a crime if their cell phone pinged right here, if they were within the radius when they said they weren't supposed to be. So this is a really good real-life example of when the area of a circle is actually something that's really relevant to something real life, like fighting crime. So let's take a look at number 6. It says the area of this circle is 28.26 feet squared. What is the diameter? So I have the area inside. I need to find this dotted line. So what you need to do is use the formula for area of a circle and then substitute in your values. So that this is the formula for area of a circle. Then I'm going to substitute in the area that I have and then the pi approximation 3.14. When I have it written like this, I have an equation because I have an equal sign and I have one variable. That means I can solve for that missing variable. So I'll draw my line on the equals and then I want to use inverse operations to get the r by itself. So if I knew what r was, I would square it, then multiply it. So I need to do the opposite. It's like taking off your shoes. You got to untie them before you take them off. So I'm going to go backwards. I'm going to do the opposite of times 3.14. That is divide by 3.14. And if I do it to one side, I have to do it to the other. That's how I get 9 equals r squared. So a number times itself gives me 9. You probably already know that number is 3, but just in case you didn't know that, the opposite of squared is square root. So if you take the square root of both sides, you end up with 3 equals the radius. The question's not asking for the radius, it's asking for the diameter. So if halfway across is 3, then all the way across would be 6. So 6 feet is your diameter, and that is the answer to the question. All right, so now let's take a look at number 7, 8, 9, and 10. Start with number 7. We're going to be able to find some real-life examples of area. So we're going to find the area of this figure. This looks like a blueprint of a house to me. In a real-life example like this, we don't always get very nice, neat, easy shapes. Sometimes we get composite figures or compound shapes. So we have here a triangle on top, and we have a rectangle on the bottom. And we'll find the area of each shape one at a time. So let's start with finding the area of the rectangle. To find the area of a rectangle, we need the base and the height. The base is 9, and the height is 8. So 9 times 8 will give you the area of the rectangle. Got 72, so 72 meters squared. Now the area of a triangle is a little bit more difficult. Area of a triangle is half the base times the height. So I have a base. The base is 9, but the height is just this distance here, from the bottom here of the triangle to the tip top. I know that all the way across, all the way up and down is 12, and I know that most of this is 8. So the part that's remaining would be 12 minus 8. That's 4. If the triangle has a base of 9 and a height of 4, I can substitute those values into my formula. Area equals half of 9 times 4, and I'm going to use my commutative property, do half of 4 first, because that is 2, and 2 times 9 is 18. So I know that the area of the triangle is 18 meters squared. So then I'm looking for the area of the whole thing. So the very last step is going to be to add 18 and 72. That gives me a total combined area of 90 meters squared for the whole shape. Let's look at number 8. So the diagram below shows a tile border. That border, oh my goodness, border is spelled all the way wrong. B-O-R-D-E-R. Shown in gray. So the border here is the gray part, and it surrounds a kiddie pool. How many square feet does the tile border cover? So in this picture, it might be a little hard to see, but the length all the way across, this 18, is referring to the very end and the very end here, including the shaded part. This 15 is referring to just this and just this where I'm pointing. That's the smaller part, just this white part. So that right there is the 15. So what you're going to do is you're going to want to take the area of the whole thing and then subtract the area of the inside. That's going to give you the area of just that tile border. So remember, area of a rectangle is base times height. So 18 times 9 will give you the area of the whole thing. Got 162 square feet. Then we need to find the area of the inside, this white part, the pool part. So 15 times 6 gives you the area of that. I got 90 square feet for it. And remember, that's just the white part. Now to find the area of the border, I'm going to subtract. The difference between the whole thing and the inside part leaves me just with the shaded area of 72 square feet, and that is the border, and that's correctly spelled. Number 9 says a square playground is covered with pebbles except for 2 equal-sized triangular portions that have grass. How many square feet do the pebbles cover? Parts I just covered in green, those are the grass parts. There's a few ways I would do this one, but I'm going to go with what I think is the easiest way. So it is a square shape. That means that every side has the same length. So if this side is 14, the whole thing, then this side is 14. So what I would start with is taking the area of the whole playground. Base times height is 14 times 14, which gives me a total combined area of 196 square feet. Now, I need to take out the grass. It's asking about how many square feet do the pebbles cover. So I need to take the area of this triangle and then subtract it. Take the area of this triangle and then subtract it. So here's what I know about this triangle. I know that these two lines mean that those are congruent. This side is the same as this side. So if this is 7, then this is 7. And I know that the area formula for a triangle is half the base times the height. I substitute in my values, half of 7 times 7. I know that the area of that triangle is 24.5 square feet. Now, looking back at the question, it says there's 2 equal-sized triangular portions. So this other triangle has the same area. So I'm going to double that area. I'm going to multiply it by 2. So the combined area of the triangles is 49 square feet. I now have 2 areas, the total area of the whole playground and the area of the green parts, the grassy areas. So I need to find the difference of those to find the area of the shaded part. So difference means subtract. So I'm going to take 196 minus 49 to get my final answer of 147 square feet. Let's go ahead and look at number 10 now. We have a basketball court, and we're going to paint everything shown below blue. So how many square feet will be painted blue? You have 2 shapes here, a rectangle and you have a half circle. So let's start with finding the area of the rectangle, because that's easy. Area of a rectangle is base times height. So 10 times 15 is what you do first. 10 times 15 is 150, so you can write that inside of the rectangle. And since it's in feet, you put square feet. We need to find the area of this half circle. I know the diameter of the half circle, but I need to find the radius. So I need half of 10. The radius of this circle is 5 feet. So then I use my formula for area of a circle. A equals pi r squared. The radius is 5, so I'm just going to substitute in my values. I know that 5 squared is 25, since it's 5 times 5, not 5 times 2. And then I multiply that number by pi. So the area of the half circle is 78.5 square feet. And we're going to add that to the area of the rectangle to get our total area of this part of the basketball court. That is how I got 189.25 square feet. Last 2 questions for this section. So let's look at number 11. It says the shaded region represents new tile being replaced on a patio. If each square foot of tile costs $2.80, then how much will the tile cost? So it's asking me to find square footage. That means area of the shaded part. So basically I need to find the area of the whole shape and then subtract the white part. So let me go ahead and find the area of this square. The area of a square is base times height. So 18 times 18 gives me the area of the whole square. 324 square feet. Now I need to take off the area of the white triangle. So I need to find the area of this triangle. To find the area of a triangle, I use the formula 1/2 times the base times the height. I'm given a base of 18 and a height of 18. So I need to do half of that. So I'm going to take what I already got from this last one, 324, and just divide it by 2. So 324 divided by 2 gives me 162 square feet. And that's the area of the triangle in white here. So now I need to find their difference, since that's what's the shade. That's going to be represented by the shaded area. So I need to subtract. So 324 minus 162 gives me 162 square feet, which makes sense because we found half of that already here. So now I'm not done. I have to find out how much it costs. It's not asking me how much area there is. It asks me how much it costs. Each square foot costs $2.80, and there's 162 square feet. So we need to multiply to find our final answer. That gives us a total dollar amount of $453.60. Let's look at number 12. It says determine the area of the shaded region and use 3 for pi. So we're going to approximate pi with the number 3 this time. So we're going to start by finding the area of the whole thing. It's a square, and we find the area of a square by using base times height. So 12 times 12 is 144. You notice I'm just making a little note here. Square's area equals 144 inches squared. You can do the same type of thing on your paper just to keep organized. And now I'm going to take out the circles. So I need to find the area of one of the circles. Do that by using the formula pi r squared. So I have 4 circles that are fitting pretty perfectly into this square. So if I take just the distance from here to here, that gives me the diameter of one circle. But I don't need the diameter, I need the radius. So I'm going to go half one more time. So this blue distance is 6 inches, and then half of that is 3 inches. And I need that 3 inches because I need to know the radius of one circle. And it says use 3 for pi. So I'm just going to substitute in my values. Let's do 3 times 3 squared. 3 squared is 9, and 9 times 3 gives me the area of one circle as 27 inches squared. So that's one circle, but there's 4 of them, and I want to know the shaded area of this shape. So I need to multiply this 27 by 4, and then subtract that number off of the 144 that I started with. When I do that, I got 162 square inches, just like in the last one, and I need to subtract that off of the 144. That gives me the shaded area of 36 square inches. Okay, so this last section is all about scale drawings. So we're going to be using scale factor and similar figures to solve these problems. 13 says that this photo below is being enlarged to form a 24 by 30 inch print. What's the scale factor being used to enlarge it? So this is the smaller dimension of the two. So this one will correspond with the 24 here. So let me go ahead and draw a rough sketch of the new rectangle. And it doesn't have to be perfect. I am just going to draw a quick sketch of this. That way I can see what corresponds with what. So the 24 obviously goes with this 4. So I'm thinking, how did I get from a 4 to a 24? I can always do that by taking the new dimension divided by the original. 24 divided by 4 gives me 6. I can do the same thing here with the 30 and the 5. It's similar, so it should be proportional, but let's just do it just to check. 30 divided by 5 is 6. So the scale factor was 6. We multiplied the dimensions of this picture by 6. I'm going to write SF equals 6 in the corner. You can write out scale factor if you want to. Number 14 says Shelby drew a map of the Appalachian Trail. The scale was 5 centimeters, represents 400 kilometers. Right away, when it tells me the scale, I'm going to go ahead and start by writing that out as a ratio. The scale factor is 5 centimeters for every 400 kilometers. Since it told me that I needed to find the actual length, and I was given the 43.75, I put that 43.75 on the top. It needs to be centimeters to match with the other fraction. And then I multiply across and divide by what's left to get this number, 3,500 kilometers. Let's go ahead and look at number 15. It says triangle ABC shown below. The original lengths are multiplied by 150%, and it's asking me for the new perimeter of A prime, B prime, C prime, the new triangle. So I'm going to start by making this percent a decimal. I know that in a percent, the decimal is at the end, and I need to move it back to a decimal by moving it to the left 2 times. That gives me 150%. Percent is the same thing as 1.5. That's the scale factor. And it's asking me for the perimeter, so I need to find the new lengths of each one of these sides. So take a second, draw the new triangle, and then multiply by the scale factor. The new triangle with your new side lengths, again, it's not exactly going to be the right size. I'm just making a rough sketch so you can see this. And it's asking me for the perimeter of this new triangle. So I am going to add all the sides. That's what perimeter is. It's all the sides added up. When you do that, you end up with 75 centimeters. Let's look at number 16. It says the map below is being reduced by a scale factor of 2/3. It's getting smaller, and we know that because I'm multiplying by a fraction. And it's printed at the subway station. How many square inches will the map take up? Start by drawing your new map, and then take 2/3 of each side. You want to multiply each one by the scale factor. So start with this green side here. 21 times 2/3, 14 inches. And then let's find the blue side here, 15 times 2/3, which is 10 inches. It's asking me about how many square inches this new map is going to take up. Square inches is the space inside. That's the area. So I need to find the area of this new figure by multiplying the base times the height. 10 times 14 will give me an area of 140 square inches. All right, let's look at 17. It says these two figures are similar. What is the length of x? Let's find the corresponding sides. 4 matches with the 10. 6 matches with the 15. And what we're going to try to find here is the scale factor. We need to know what it's being multiplied by, and it's not something you can easily tell. So the way to figure that out is to find the ratio of the new image divided by the original image. That rule will work every time. The new divided by the old. 15 divided by 6 gives me 2.5. Same for 10 divided by 4. So I know that the scale factor to get from this to this is multiplying by 2.5. It's an enlargement. So I'm going to take 8 times 2.5 to find x, which is how I got a length of 20 inches. That's for this right here. Let's look at 18, last one. The two triangles below are similar. What's the perimeter of triangle XYZ? So let's start by filling in the rest of the lengths for XYZ, the new triangle. We need to do that by finding the scale factor. So I know that the corresponding sides, LN, match with XZ. The new triangle is 6 over the original triangle's 15. 6 over 15 is 0.4, or you can think about that as 4/10, which is the same thing as 2/5, same thing as 40%. So I want you to think about it all these different ways because you might see those anytime. And what I want you to do for each one of these other side lengths is multiply those by 4/10 or 0.4 and to get the other corresponding sides of the similar figure. And when you do that, this is what you should get right here. And it's asking for the perimeter, which is all these sides added up. So 8 plus 10 plus 6 gives you a total perimeter of 24 centimeters, And that's it. So if you made it to the end of this video, I hope that you got your questions answered. If you didn't, please let me know, and I will help you in any way that I can. Good luck on your test.